Hello and welcome to the Laba 7 Shock Dyno software demo. In this video, we'll show you the ins and outs of the software, how it works, and some interesting features. But before we start, here are some facts you should know. The Laba 7 Shock Dyno software comes free of charge with the purchase of your Shock Dyno. Once the Shock Dyno is set up, you'll have a free one-on-one online training session with our tech support team who will guide you through the software. You can download an in-depth user manual in one of the links in the description below. Our software includes an automatic update system that keeps you on the latest stable release. For those of you who want early access to upcoming functionalities, beta versions will also be available. And number 5, if you need any specific features, let us know. Our developers can add it to a future update. Before you start testing, let's quickly set up your Laba 7 Shock Dyno software. First, install the software using the file from the official Laba 7 website or provided by your representative.
After installation, launch the application and click the gear icon in the top right corner. Under the Dyno Settings tab, click Add to create a new Dyno profile. You can rename this profile by double-clicking its name.
Next, you'll connect your Dyno. This process depends on whether you have an EMA Dyno or a Scotch-Yoke Dyno.
For EMA Dynos, turn on the Dyno. If using Ethernet, connect the LAN cable. Enter the IP address displayed on your EMA screen and wait for the green online indicator. Wi-Fi instructions are in your manual. For Shock Dynos of type Scotch-Yoke, turn on the Dyno, connect it to your laptop via USB, choose USB communication, and select the correct COM port. One is reserved for logs. When connected, the status indicator turns green. Wi-Fi instructions are in your user manual.
At this point, you can select the default data catalog for saving test results, but you can also configure that later. And that's it, you're ready to begin testing. Now that your Shock Dyno is connected, let's quickly look at customizing the Laba 7 Shock Dyno software to match your workflow.
In general settings, you can easily switch between metric and imperial units. Select your preferred language and adjust date and time formats. You can upload your shop's logo, which will appear on test reports, and add personal or company contact information to display at the top of every printed report. You also have control over specific testing preferences. For example, you can enable or disable automatic saving of warm-up tests, invert graph access to suit your viewing preference, or even require comments before tests can be saved, making sure all essential information is recorded.
If you have an EMA Dyno, some additional advanced customization options are available with specialized license keys.
If you're using an external data logger with custom sensors, you can enable custom data sensors. Here you'll set sampling rates and output voltages, choose between single-ended or differential signal channels, and apply filtering to raw sensor data if needed. Each channel is configurable individually, allowing you to specify names, multipliers, offsets, and units of precise, tailored data collection. For manufacturers or high-volume testing environments, the manufacturing mode license provides powerful features. You can enable manufacturing mode with operator passwords for secure access. This allows you to set clear pass-fail criteria and integrate barcode schemes for quick automatic damper validation. You can also automate test summaries, enable automatic test continuation for faster workflows, adjust load cell filtering on Scotch-Yoke Dynos, and define default settings for preload and first-run average force elimination.
These customization options help ensure the software fits perfectly into your specific testing processes. Every time you install a new damper on a dyno, it's best to start with a clean slate by creating a new project.
Click the Project tab, then select New Project. Now enter your damper details: manufacturer, model size, piston size, damping type, oil type, valving setup, and whether it has an external reservoir. You can also include optional notes such as vehicle details, rider or driver feedback, or baseline settings for a previous build. These notes are not mandatory, but they are very helpful later when comparing data or diagnosing issues. In addition to these standard fields, the software lets you create your own custom fields. To do this, simply type the custom field name and add it to the project. You can create as many custom fields as you need. Once you're satisfied with your custom fields, you can save them as a default template. This way, these fields will appear automatically each time you start a new project.
The more detailed and consistent your project setup is, The easier it becomes to identify patterns, compare test results, and revisit data with meaningful context later on. Once the project is saved, all test intervals and runs will be stored under that entry for future access and analysis. This segment applies only to Scotch-Yoke shock dynos. If you have an EMA dyno, calibration is not required and you can skip directly to the next section.
Before running any tests, make sure the damper is securely mounted and the dyno mast is at 6 o'clock position, or the lowest.
Typically, the dyno stops automatically at this position after each test. However, if you are manually changing the stroke or installing a new damper, simply double check and set it to the bottom position before running calibration. The calibration process is automatic and only requires a click of a button. Here's how to do it.
On the Laba 7 shock dyno software, go to the Testing tab and then click Calibrate. The calibration step measures your current stroke length and preload force. We recommend calibrating your dyno before every test.
This process helps the software establish baseline conditions, which ensures that all test data is consistent and meaningful. Once calibration is complete on your Scotch-Yoke dyno, it's time to run your test. Ensure that the temperature sensor is directed at the shock body. If the surface is reflective, like chrome-plated for example, place a bit of tape to improve accuracy.
Start with a warm-up. This test brings the damper up to its normal operating temperature. Just enter your target temperature and preferred warm-up speed. You can also set optional force or time limits if needed. After that, define your intervals. These are the actual test runs. For each interval, input the desired speed and duration and optionally set force or temperature limits. Name the test, add a short comment if needed, and press Start Test. The dyno will automatically carry out the intervals in the order they were entered.
Each run collects data for analysis, and depending on the speed and stroke settings, the software ensures enough rotation cycles are completed for accurate graph generation. If the target temperature isn't reached within the defined time limit, the test shuts off automatically. This prevents unnecessary cycling and avoids overheating. After the test is complete, the results are shown in graph form. Several graph types are available. Each one reveals something different about damper behavior. No single graph reveals the full picture. Instead, they work together to help you understand how the shock performs under different conditions.
Force versus displacement shows how the damper reacts through its stroke. It's ideal for spotting hysteresis, symmetry, and overall damping characteristics. Force versus velocity focuses on how the damping forces changes with speed. This is often used to evaluate valving behavior and compression rebound balance. Average and combined velocity graphs remove hysteresis loops and isolate average trends. Great for comparing setups or visualizing tuning changes. Peak velocity plot, or PVP, summarizes performance across different speeds. It's especially helpful when working with interval-based testing or when you need a quick comparison of compression and rebound forces at peak values. Also, there are force versus time and temperature versus time graphs.
Now an important detail.
You can toggle between graph and channel mode at any time.
These modes are interchangeable depending on what you're testing and what kind of analysis you need.
Graph mode is built around sinusoidal motion, which is standard for most shock dynos. It's ideal for typical test cycles and basic performance evaluation. Channel mode, on the other hand, unlocks more flexibility. It supports non-sinusoidal motion, including complex, custom movement profiles such as step inputs or real-world simulation curves. It also allows for custom graph creation, so you are not limited to the default views. This is useful when testing with electromagnetic actuator systems or when you want to replicate very specific force-velocity patterns.
Keep one thing in mind. Switching modes doesn't change your raw test data. It simply adjusts how the software interprets and visualizes it.
Once your graphs are ready, you can zoom in, overlay runs, add data points, or export everything for reporting or deeper analysis.
These tools are here to help you not just see results, but also analyze and understand them. The EMA operates differently from Scotch-Yoke dynos, so instead of calibration, the operator must set system safety parameters.
In the system configuration panel, you can define limits for maximum force, velocity, shaft position, motor torque, and allowable damper temperature. These limits ensure the test remains within safe and controlled operating conditions.
For example, if you're testing a small shock or running early-stage development parts, reducing these values might help prevent accidental overload or damage. The system will automatically stop the test if any of these thresholds are exceeded. Standard sinusoidal testing is a great way to characterize shock absorber behavior under controlled conditions. But if you have an EMA, the Laba 7 Shock Dyno will take you further. It offers advanced testing profiles that simulate real-world inputs or allow for more targeted diagnostics. Let's break down the options. The Laba 7 EMA software includes a control loop configuration tool that allows advanced users fine-tune how the actuator responds during testing.
Using control loop configuration, you can adjust how the system tracks motion, corrects deviations, and responds to damping loads. This becomes critical when testing high-speed dampers or components with aggressive valving, where precise control over the motor response can reduce overshoot, stabilize performance, and improve data quality.
These settings should be adjusted carefully. If you're unsure where to start, Laba 7's technical support team can provide documentation or guidance based on your specific application.
When setting up interval-based tests, you can choose between different waveform types. Sine wave, ideal for general testing. This creates smooth, repeatable motion that's easy to analyze across force and velocity graphs. Constant velocity, this keeps the shaft speed steady throughout the stroke and helps study force consistency. Constant acceleration, used to evaluate how the damper reacts to changes in load and inertia. You can also define preload, stroke, speeds for compression and rebound, and sampling rates. Multiple intervals with different waveforms and parameters can be chained together for sequential testing. The impulse test mode allows you to apply a single, non-repeating force input to the damper. Unlike interval tests, which repeat for multiple cycles, an impulse is executed once and held for a defined duration. This type of test is ideal for evaluating how the damper reacts to sudden displacement events such as bottoming out or seal transition behavior. You can set the stop position, shaft speed, hold time, and delay before the next test. Impulse testing is especially useful in diagnostics or when simulating short, high-load events that are difficult to replicate with sinusoidal motion.
The noise generator lets you simulate complex, naturalistic damper inputs by generating either chirp, sweep, or pink noise.
Chirp in Laba 7 software is a signal where the frequency increases over time while the amplitude decreases. It's ideal for identifying dynamic response ranges, resonances, or phase lags across the stroke. Sweep, on the other hand, is when the amplitude stays fixed while the frequency increases. A sweep applies discrete frequency bands in segments, holding each frequency for a set time before moving to the next. This is useful when you want to see how the damper behaves at specific controlled frequencies such as 1 Hz, 3 Hz, 5 Hz, and 7 Hz. Pink noise is a randomized signal that mimics real terrain input. It distributes energy more naturally across frequencies and is often used to simulate unpredictable environments like gravel, trail, or rough tarmac.
You can define test duration, stroke, and frequency range. These tests help reveal behaviors that wouldn't appear under clean repetitive motion. For the most realistic testing, you can import real-world telemetry from a race car, motorcycle, or mountain bike.
Simply upload your CSV file, select the unit format and the damper position, front or rear, and apply filtering if needed. You can also trim the dataset to focus on a specific section of a lap or segment. This allows you to recreate real track conditions, like cornering loads, whoops, braking bumps on the dyno in a controlled, repeatable way. Even small adjustments like rebound clicker changes can be tested against actual motion to see if they improve or worsen performance in that specific scenario. What is more, after importing telemetry data and executing a test, you can compare the original motion curve to the actual result. This feature helps verify how closely the EMA followed the real-world input, and it gives you a clearer picture of how the damper performed under authentic conditions.
These advanced profiles let you move beyond sinusoidal motion and start replicating real-world conditions. Whether you're exploring valve response with a chirp test, simulating terrain with pink noise, or recreating a lap from live telemetry, the Laba 7 software gives you the tools to test what really matters. The real value of a test isn't just collecting data, it's being able to explore it. The Laba 7 Shock Dyno software includes several tools that allow you to isolate trends, compare variations, and interpret results with greater accuracy.
First, you can open the graph in a separate window by clicking the arrow out of the box icon in the upper right corner. It helps you cross-reference different performance metrics side by side, which improves your ability to interpret the damper's behavior more completely and accurately.
Or to put it in simple terms, with multiple graph views open, you can spot correlations that aren't obvious in a single graph.
Next, you can zoom in and out using your mouse scroll wheel. Or you can select a specific section of the graph by clicking the right mouse button and dragging the cursor. Zooming works both vertically and horizontally. Just hover over the axis you want to control. This lets you focus on very small irregularities in the data that might not be visible at normal scale.
You can also mark specific data points by left-clicking on a graph.
The exact force and velocity values at that point will be displayed. You can place multiple markers and right-click anywhere to clear them. If you go to Reporting, then Spring, and choose Current Graph, those marked points will be included in the printed report.
This is especially useful when you need to highlight specific findings for a customer or a colleague.
Lastly, it's worth mentioning that in the EMA data mode, you can view up to 6 different data curves in a single graph window. These include not just mechanical outputs like force and displacement, but also motor data like current draw and system temperature. They are very helpful for validating the test environment or detecting hardware limits.
These tools are more than just a visual. They give you control over how you interpret and communicate results. Whether you're troubleshooting, refining a setup, or preparing a report, being able to interact with the graph directly makes the analysis more precise and more efficient. Graph comparison is especially useful when evaluating changes between builds, settings, or component swaps.
To compare multiple runs, either from the same shock or different setups, navigate back to the main screen and open the project from the list on the left. Select the specific test runs you like to view together. The graphs will be overlaid for direct comparison. You can change the line color for each run, add visual markers, and zoom in on areas of interest.
This feature makes it easier to identify even the most subtle performance differences and supports more informed decision-making during tuning or setup. The test summary window offers additional tools to refine your data.
You can remove the effects of spring force by entering a known spring rate, create and apply custom data fields for tracking things like serial number, build specs, or tuning notes, and normalize all runs by subtracting the average of the first test interval, a useful tool when running progressive tests.
These adjustments don't change the raw data. They help clarify the graphs and improve consistency across tests. Once your testing and analysis are complete, you can generate detailed reports.
Click the Reporting tab and choose a format. Individual Tests shows each run on a separate page. Comparison Report overlays multiple runs in a single graph. PVP Report focuses on peak velocity curves and intervals. You can print these reports or save them as PDFs, with optional comments and formatting choices. If you need to export your test data, select the desired runs and export them as .csv files. You can export individual tests, peak velocity plots, or average velocity curves.
Reports can be a powerful tool at your disposal. They're useful for documenting test results, providing quality assurance evidence to customers, or sharing test results between colleagues or departments. In addition to running and exporting test results, the Laba 7 software also allows you to import data. That is useful when you want to compare test results with your existing test repository.
You can import older Laba 7 test files, .csv files generated from previous software versions, or even data from other shock dyno systems. If you have used a shock dyno from another leading manufacturer, there's a good chance you'll be able to open your archived test files directly in the Laba 7 shock dyno software.
To find out which formats are supported, just reach out to us at laba7.com. Bringing your past data into one place makes it easier to compare, reference, or build upon your existing testing knowledge without starting from scratch. That wraps up our overview of the Laba 7 Shock Dyno software. From setting up your first test to analyzing results, comparing runs, and generating reports, the Laba 7 software is designed to support real-world testing, whether you're in a workshop, a race team, or an R&D lab. If you have questions, need support, or want to explore advanced features, our team is ready to help. You can also find the full user manual and contact details at laba7.com. Thank you for watching and see you next time.